So our first question that we have is, a satellite is orbiting just above the surface of Earth with period T. Okay. It is given to us, let's say Earth is there and a satellite is orbiting just above the surface. You know? So basically what information do we get from this? That the orbital radius of satellite, if let's say satellite is, we take over here, this is our satellite, let's say of mass small m. So the orbital radius, how much we will take it? Orbital radius will be equals to radius of Earth only. Very near to the surface, that means orbital radius is just above the surface, that means your orbital radius is equals to radius of Earth. Fine. If d is the average density of the Earth, okay, and g is universal gravitation constant, then the quantity 3 pi by gd represents, okay, 3 pi by gd in terms of time period. So what do we know? What is our time period? Time period for a satellite is given as 2 pi by root gm r power 3 by 2. I hope all of you know this result, important result, time period of satellite. Now in this we have to get this thing, 3 pi by gd value in terms of t. What I'll do is, let us square it to simplify. T square will be 4 pi square by gm. This is r power 3 by 2. If we square it, we will get it r cube. And this r is actually in the question small r, the orbital radius is nothing but the radius of Earth only we have to take. So we'll get r cube. Fine, well and good. We want in terms of density, mass. What can we write it? Mass can be written as density d into volume. How much it is? 4 by 3 pi r cube. Fine, well and good. Let's take it over here. So t square is equals to 4 pi r square r cube by g, capital G, into m. M value we got it as density into volume, 4 by 3 pi r cube. What we are left with? 4 cancels out, pi cancel, r cube cancel out. So t square is equals to 3 pi by gd. 3 pi by gd, right? What is our value of 3 pi by gd? It is t square. T square, that means which option it will be? Option number 1. Option number 1 is our correct answer, right? Let's look at the next question. Yeah, our next question is again 23 question only. Two bodies of mass m and n 9m are placed at a distance r. Okay, m and 9m are placed at a distance of r. Well and good. Next he says the gravitational potential on the line joining the bodies where gravitational field equals 0 will be. Okay, they are asking us gravitational potential. Gravitational potential, 2 points are there. First of all, let us see what is gravitational potential due to a point mass. Gravitational potential due to a point mass is written as minus gm by r. I hope this formula you know it. Gravitational potential due to a point mass is given as minus gm by r. But the issue is, we know the two masses m and 9m, we don't know the position. For position, where we have to find out, they have given, you have to find on the point, at the point where your gravitational field is 0. Where gravitational field will be 0, beta? Because this is your m, 9m, let's say somewhere over here, point P. We'll have to first find out the position of the point where gravitational field is 0. So what I have assumed is that this is our point P, somewhere in between it. Obviously it will be closer to the mass m, but let's say that this point P is at a distance of x from m. So from 9m it will be at a distance of r minus x. Now what do we write down? Gravitational field due to this m, how much it will be? Let us call this as A and this as B, so that it is convenient for us. So due to this, gravitational field will be towards the mass, it will be your GA. Due to B, it will be again towards the mass, it will be GB. If gravitational field at this point P has to be 0, that implies these two should be equal in magnitude. Net gravitational field at this point P should be 0. When that will happen? When the magnitudes are equal, because direction wise they are opposite. Because gravitational field will be towards the masses, so they are opposite to each other direction wise. So when, if they become magnitude wise equal, it will become 0. So G net at point P is 0. G net at point P is 0. That implies, so for that we know gravitational field due to A should be equals to gravitational field due to B. Let us see. What can I write it? Gravitational field due to A. Gravitational field relation. What is gravitational field due to a point mass? Gm by r square. This is what is our general result, right? Gravitational field due to a mass m at a distance r is given as Gm by r square. Now let us write down due to A mass, it will be beta Gm by x square. This is equals to due to 9m. So G 9m by how much is the distance? R minus x whole square. Fine. G cancel, m cancel. We are getting over here. R minus x whole square is equals to 9x square, right? If we take square root over here, we can take r minus x is equals to 3x. So r is equals to 4x and x value comes out r by 4. X value is coming r by 4, right? We got x as r by 4. Now that means this P point is at a distance of r by 4. We need to write down potential at a point which is present at r by 4 from A and 3r by 4. If r by 4 is from here, then over here it will be r minus r by 4, 3r by 4 from B. Let us write down potential. V net. Potential is a scalar quantity, Potential is a scalar quantity. So what can we write it directly? VA plus VB. Potential due to A, what can I write it? Minus Gm by distance. Distance for this one we got it as r by 4. If I put it over here, r by 4. Due to B it will be minus of G9m by distance is your 3r by 4. 3 times this becomes your 12. So we have minus 4 Gm by r minus of 12 Gm by r. Finally, what is our answer coming? If you see, minus 16 Gm by r. Okay. It was kind of a good question. Yes, we can say that. So our answer is minus 16 Gm by r. Option number, if you see, it's option number 2. Second option is our correct answer, right? Minus 16 Gm by r. Let us look at our next question. Yeah. So our question says the escape velocity from the Earth's surface is v. Fine. Escape velocity from the Earth's surface is v. What is our relation for escape velocity? V is root over 2gm by r. Fine. The escape velocity from the surface of another planet having a radius 4 times that of Earth. Another planet is there whose radius of planet is 4 times the radius of Earth. Fine. And same mass density. Density of planet is same as density of Earth. Fine, well and good. So they are asking us your escape velocity from this one. Escape velocity from the planet, VEP. What can we write it? This is the relation given. What we do is, let us convert this in terms of density and radius only. Let us convert this escape velocity result in terms of density and radius. How can we do it? V is equals to root over 2g m. M mass can be written as what? Density into volume. 4 by 3 pi r cube by r. 1 r cancel, will have r square. So V value will come out root over 8 by 3 g rho pi r square. ठीक है, 8 by 3 g pi constant, that means V is proportional to root over rho r square. Now see carefully over here, because for the planet the density is same, so we can write down V value will be what? V dash. For the planet we can write down it is rho times into r of planet, right, which will be k. Over here we can put a constant k. So V dash is equals to k into rho into rp. Rp is your radius of the planet, which is 4 times radius of Earth. All these things are constant, so that implies your V dash, that is escape velocity on the planet. This is your escape velocity on the planet is 4 times the escape velocity on Earth, 4V. 4V is our answer, which is option number 4, right? Let's look at next question. Yeah. So next question is, a particle of mass m is projected with a velocity v is equals to k times ve. Okay. So a particle of mass small m is projected with the speed of k times ve. Here k is less than 1 and v is the escape velocity. Fine, well and good. If k is less than 1, that implies obviously it will not escape the gravitational pull of it. It will reach to some height and then its speed will become 0. This is what it is. Is it visible? Height h basically. Okay. Now they are asking the maximum height above the surface reached by the particle. Sorry, how to deal with this question? So this is a question from your gravitation, where we will have to use your energy conservation. What energy conservation? Mechanical energy conservation. If I have to write, k initial plus u initial equals to k final plus u final. K initial plus u initial. This is writing on the surface when it is being ejected, and this is at the highest point where its speed will become 0, right? So initial kinetic energy can be written as half mve square, or sorry, this v square, half mv square. Potential energy on the surface will be minus g capital M. Capital M is the mass of Earth into small m by on the surface r. Final kinetic energy at the highest point, kinetic speed will become 0, so kinetic energy also 0. At the highest point, potential energy will be minus g capital M small m by separation. Separation is measured from the center. From the center, that means r plus h. Okay. Now let us simplify this. V value beta. What is V value given to us? It is k times escape velocity. So V is k times escape velocity. What is our escape velocity? Root over 2g capital M by r. This is our escape velocity. If we square it, we will get over here half m square of v square. It will be k square g k square 2gm by r. 2 cancels out. So minus gmm by r is equals to minus gmm by r plus h. Fine. Let us simplify this. Over here I am getting k square gmm by r, same thing, right? Next, what can you see is gmm by r, we can take common. So if we take common gmm by r, we are left with k square minus 1 is equals to minus of gmm by r plus h. Fine, well and good. Gmm cancel out. Now, this is capital M, mass of Earth. Small m is the mass of the particle object which is being thrown or emitted, ejected from this. So, gmm cancels out. Ultimately, what we have, this minus sign, if I take it over here, if minus sign I take it over here, we will get it 1 minus k square by r is equals to 1 by r plus h. Okay? I'll take the reciprocal. So, we will get over here r plus h is equals to r by 1 minus k square. Fine. H value, we want to find out h value. H is equals to r by 1 minus k square minus of r. R can be taken common and we'll take the LCM. So, we will get it 1 by 1 of minus of 1 plus k square by 1 minus k square. 1 cancels out. H is r k square by 1 minus k square. Okay, this is our h value. Which option we are getting? Option number 4. Option number 4 is our answer. Just be careful with the calculation part, we need to do it carefully. Remaining question was a decent good question, and I hope everyone understood it. So let's look at next question. Yeah, so about question says a body weighs 72 Newton on the surface of Earth. Okay, on the surface of Earth the body weighs 72 Newton. What is weight? Weight is basically m into g, the gravitational force. So mg value is 72 Newton given to us. Fine. What is the gravitational force on it at a height equal to half the radius of Earth? Half the radius of Earth at a height h equals to r by 2. What is the gravitational force? What is gravitational force, beta? Gravitational force is nothing but your m into g dash. M into g dash, gravitational force is mg. What is it? G will change at height h. G will change at height h. So we want to find out this. If somehow we can calculate g dash, that is, this question is from variation of g with height. What is the result? So we want to find out mg dash. Now what is our variation of g with height? What is our result? Result says g at height h is equals to g times r by r plus h whole square. So gh is equals to g times r by r plus r by 2 whole square. So when we simplify it, we will get gh is equals to g times 2r by 3r whole square. R cancel. We are left with gh is equals to 4 by 9g. Well and good. Once we got our g value at height h, so what can we write it? Weight at height h, weight or the gravitational force, which is equals to m into gh. So m into gh value is how much? 4 by 9g. 4 by 9g. So I'll write it 4 by 9 mg. Now mg value is given to us as 72 Newton. So 4 by 9 into 72. 8 times 32. 8 4 is 32. So we have 32 Newton will be the gravitational force at height of r by 2, right? Let's look at next question. Yeah. So next question is work done to raise a mass m from the surface of Earth to a height h. Okay. Let's say this is Earth, and we are taking it as mass capital M, small m mass, which is being raised from the surface to a height h, and this height h is given to us how much? To a height h which is equal to radius of the Earth, which is equals to radius of the Earth. So h is equals to r. H is equals to r, that is radius of Earth. Fine, well and good. Work done. What is work done? How do we calculate? We can't apply force into displacement. Work done is what? In terms of change in potential energy. Work done will be change in potential energy, which is delta U. So this we can write as U final minus U initial, right? Potential energy, gravitational potential energy for two masses, what do we write it? Minus G m1 m2 by r. Now this distance r is measured from center to center. So final potential energy at this height can be written as minus G capital M, that is mass of Earth, small m mass of the body, by R is how much? From the center if you measure, it will be R plus R, that is 2R minus of initial gravitational potential energy will be minus Gmm by R. When we simplify it, minus Gmm by 2R minus minus plus Gmm by R, right? How much we will get it, beta? Gmm by 2R. ठीक है, 1 minus 1 by 2. This is your work done. But if you look at the answer, in the answer it is not given in terms of capital G or M. They have given in terms of small g. How to deal with it? So basically this Gm by R square is what? Small g. So what can we write it? Gm by R can be written as G into R. Please remember this many a times in question. This is very helpful. So we'll be using this. So work done is equals to this term Gm by R can be written as small gr. So 1 by 2 mgr. Okay, this is our answer. Now check the option. Option number 3, 1 by 2 mgr will be our correct answer, right? Yeah. So our question is, the kinetic energy of a planet in an elliptical orbit around Sun at position A, B and C are K, KB, KC respectively. AC is the major axis and SB is perpendicular to AC at the position of Sun S as shown in figure. Then, okay. So beta, kinetic energy, 3 different positions are shown to you. This is a question basically from your Kepler's law. This is a question from Kepler's law where A, B and C. Fine. This is position A, this is position B, this is position C, right? Now, in Kepler's law, we know that from Kepler's law, our knowledge says that when the planet is near to the Sun, this is our Sun at one of the foci, when planet is near to the Sun, its speed is maximum. When planet is near to the Sun, its speed is maximum, whereas when planet is farthest away from the Sun, your speed is minimum. Right. So from that we can get, if the speed is maximum at nearest point, that implies kinetic energy at A will be maximum and kinetic energy at C will be minimum. So that implies we can write Ka will be greater than Kb, which should be greater than Kc. Right. Let's look at next question. Okay. So next we have a theoretical question. It is from 2017. Next is a theoretical question. It is, 2 astronauts are floating in gravitational free space after having lost contact with their spaceship. The two will. 4 options are given to you. Basically, the astronauts have lost contact and they are floating in free space. This is what is given. 4 options. Keep floating at the same distance between them. Second is move towards each other. Third is move away from each other, will become stationary. Now, what is the thing? So basically, what will happen, that will determine on the force. Their movement, their motion will be determined by the force. 2 bodies of masses m, basically 2 bodies of masses m, what happens? They attract each other due to gravitational force, and if they will have an attractive gravitational force, that means they will come towards each other, they will move towards each other, although very slowly, but yes, they will be coming towards each other. So our option will be move towards each other. B option is our correct answer. Yeah. So the next question says, acceleration due to gravity at a height 1 kilometer above the earth, okay, at a height 1 kilometer above the earth is same as at a depth d below the surface of earth. Fine. Let's say this is point A, this is your point B. Okay. Then d is equals to, fine, well and good. Now beta, they have given us that acceleration due to gravity at B point, which is at depth d, is equals to acceleration due to gravity at point A, which is at height 1 kilometer. Now important thing over here, we should understand, height is 1 kilometer. Height is 1 kilometer. That means h is very less than re, radius of earth. Radius of earth is 6400 kilometer. We have 2 relations for variation of g with height. We have 2 relations for variation of g with height. Which relation we will be using? The one which is the approximation result, right, which is used for height very less than RE. What is that result? G at height h is G times 1 minus 2h by R. I hope everyone's okay with this, right? So let us write down G at A is G times 1 minus 2h. How much is our height? 1 by R. This is equals to G at depth. What is our G at depth? G at depth is given as G times 1 minus D by R. Fine, let us substitute G times 1 minus D by R. G and G cancel, so 1 minus D by R is equals to 1 minus 2 by R. 1 minus 1 0, we will get D by R is equals to 2 by R. R and R cancel, D value comes out 2 kilometer. So our answer for D is 2 kilometer, right? Decent question. Just the thing is we had to keep this in mind, which relation we have to use it. Fine. Yeah. So our question says, at what height from the surface of Earth the gravitational potential and the value of G are? Okay, let's consider Earth. Let's say mass is capital M. Value of gravitational potential and G. Gravitational potential, what is gravitational potential? Which is V is given as minus 5.4 into 10 power 7 joule per kg square. Fine. And small g value is given as 6 meter per second square. Okay. They are asking us the height, and information that they have given is take radius as 6,400 kilometer, which we know 6,400 kilometer. At what height this value is there? Now beta, how to do it? First of all, let us write down what is potential. Potential is minus of gm by small r. Small r, the distance measured from the center. So this I can write as minus gm by radius plus height h, right? Gravitational field or acceleration due to gravity, small g, will be written as gm by r square, which I can write as gm by r plus h whole square, right? Further, this thing I can write as gm by r plus h into r plus h. Why I have done like this? Because if you notice, gm by r plus h can be written as what? Gm by r plus h from this potential equation can be written as minus v. It can be written as minus v. So we will get over here g is equals to minus v by r plus h. Fine, well and good. Let us simplify this further. Is it visible there? Huh. So r plus h is equals to minus of v by g. V value is given to us minus 5.4 into 10 power 7. So minus minus will become plus. So r is 6,400 kilometer into 10 power 3 plus h is equals to minus minus plus, that is 5.4 into 10 power 7 divided by g value, which is given to us 6. Okay, right? Now, so 5.4, this will become 10 power 6. 9 times. So h is equals to 9 into 10 power 6 minus of, this is 10 power 3, 10 power 2, this we can write as 64 into 10 power 5. Let us rearrange it further. 9 into 10 power 6 minus this can be written as 6.4 into 10 power 6, right? 6.4 into 10 power 6. If we further simplify it, 10 power 6 can be taken common. 9 minus 6.4, how much it will be? 2.6, right? 2.6 will be our, so h is 2.6 into 10 power 6 meter. This will come out to be meter. If we convert it into kilometer, that is divided by 1000, we will get our answer is 2600 kilometer. Okay, 2600 kilometer. So our answer is option C. Option C is our correct answer, right? Yeah. So our last question of this session is, the question says the ratio of escape velocity at Earth to escape velocity at a planet. Fine. Escape velocity at Earth to escape velocity at a planet. They are asking us if the information that is given is whose radius and mean density are twice as that of Earth. Fine, well and good. That means radius of the planet is 2 times radius of Earth and density of planet is 2 times density of earth. This information is given to us. Now beta, in previous questions in this video only, you know that escape velocity is directly proportional to root over rho r square. You know, we derived it in previous question. In this video only, escape velocity is proportional to root over rho r square. So if we take the ratio, we can write it escape velocity of earth by escape velocity of planet. This will be equals to root over density of planet by density of, sorry, this will be earth, density of earth by density of planet, into root r square will be r only. So r of earth by r of planet. Let's substitute root rho e by density of this will come out to be root 2 into root over rho e into radius of earth. Radius of planet is 2 times the radius of earth. So this cancels out. Our answer is coming 1 by 2 root 2. The ratio that comes out is 1 by 2 root 2. Right? I hope you understood this. So with this, our this last 8 years of NEET questions PYQ, we have done it. I hope you found this video helpful, and if you learned something from it, do consider to press the like button and subscribe to the channel. Thank you very much. Bye bye.